Hi everyone, this is Karthik, maintainer on the Litmus project. Welcome to the Litmus tutorial.
Hi guys, this is Uma Mokara, maintainer 2 on the Litmus project. In this video, we're going to talk more details about Litmus architecture, the schema, and the CRDs of the experiment, chaos engine, and the chaos result. So this will be helpful for those who want to know more technical details about the project as well as those who are trying to contribute to the project. So let's get on to it. So in this video, we're going to take a brief look at what are the Litmus components and how those components are onboarded onto your Kubernetes cluster. And then Karthik will take us through a detailed specification of those YAML files and how they interact with each other. Those details will be given in depth. So first, at the outset, what are the Litmus components that you have, right? So you already have readily available experiments on the hub. That's a great start for anyone. You start by installing Litmus through Helm chart or through YAML manifest onto your Kubernetes cluster. So during installation, you get an operator and set of CRDs are installed, and the scheduler, metrics exporter, and event exporter are also installed. So metrics exporter is this is Prometheus metrics exporter. This is for analytics. Event exporter or for event correlation later on. Scheduler will be used in case you want to schedule it, not just run once. You can do a recurring schedule, all that stuff. So at runtime, once this is installed onto your cluster, at runtime you start by creating a chaos experiment YAMLs CRs onto your cluster. Because they are already available on Chaos Hub, your first step is you pull them, the ones that you require, and then you start creating Chaos Engine YAML. So Chaos Engine YAML is the one that has both the information about where you're going to run chaos, that is which application, pod, all that stuff, and what experiments you're going to run. So these two information you provide in Chaos Engine. The moment you apply that on your cluster, Chaos operator is going to watch, and then it launches a Chaos runner pod. So Chaos runner will know what experiments to run, and those are launched as Chaos jobs. So each experiment will run within a job, Kubernetes job, and then finally Chaos result. If you are running multiple experiments, then multiple chaos result CRs will be created. So this is how in general it works, but Karthik is going to give us an in-depth explanation about these components in action. Karthik, over to you.
Okay, so let's see the LitmusChaos architecture, and we're going to do that with the help of an actual experiment execution. So we'll work backwards. We are going to run the chaos experiment, and as you might know, it is going to consist of these steps. Installation of the Litmus operator. We are going to use the manifest to install Litmus. We're going to pull the chaos experiment charts from the Chaos Hub. We're going to do a pod delete experiment. So that is the hello world of the chaos engineering. We are going to start with that. We're going to set up a chaos service account in admin mode. Like you already know, the admin mode operation is where you have centralized control of all the chaos resources. And this is the preferred mode when you have autonomous control over your clusters, or you might be getting started with Litmus on a development cluster. Namespace mode is something that's preferable when you have large clusters with a lot of users running it and they want namespace control. We're going to construct the chaos engine, which is the user-facing primary chaos CR in Litmus. We're going to trigger the experiment by applying this chaos engine. Then we are going to view the chaos result. The experiment state is stored in chaos result, and we are going to view how that is going to change over the experiment execution. So at each stage, I'm going to take a pause and we'll take a look at what all components are getting involved when we perform these steps and how they tie into the overall Litmus architecture. Okay, so let's get started. I'm going to install the Litmus operator first. This is going to install the Litmus operator as well as the CRDs. And it's also going to create the service account that is necessary for running this operator. So this operator is being run in cluster-wide mode, and it is actually going to watch the chaos resources, engine resources created across different namespaces. So we've got this, and let's see what all this involves, what all this is going to install. We are going to create namespace called Litmus as part of this installation. There is a chaos operator that you see, which is running now. And there are a lot of custom resources that have got created. The chaos engine, the chaos experiments, and the chaos results are the primary ones. There are a few more, chaos schedule notably, but we'll talk about that in a bit. Let's start simple. So we've got these three main custom resources. And there are the service accounts that have got created that are necessary for the operator's execution. So the next step is to pull the experiments from the Chaos Hub. Before we do that, let's take a look at the components. So we mentioned that when you install Litmus, there are going to be some main components that get created. The Chaos operator is something that you have seen already. The Chaos monitor is an optional component. This is something that we're not showing in this demonstration, but we could always do a next one where we talk about monitoring enabled. You can actually see graphs of your chaos experiments, whether how many pass or failed experiments, what the total experiment counts, etc. And we are actually going to pull things from the Chaos Hub, and we are actually going to run this on an Nginx application. Let me show you the application against which I'm going to do my chaos. It's a simple Nginx deployment. There's a single replica in it, and I have annotated it for chaos. What does this mean? This means that I've actually gone ahead and said that this application is going to lend itself to chaos. It is going to be a target of chaos, right? And it is having a label called run equals to Nginx. This label has been propagated into the pods as well. It's there on the pod template spec. That is a necessity for Litmus to identify and queue these pods. So you can see the same is available here. And I have actually got the Chaos Hub open. You can actually see the Chaos Hub here. There are different categories of experiments. The generic chaos is the one that is going to contain the pod delete experiment. So generic chaos corresponds to the standard Kubernetes resource chaos. I am actually going to pull the experiment from here. You can see the instructions. So let me just copy this. I'm going to install it, and I'm going to install it in the Litmus namespace. Remember that we are going to do this experiment in the admin mode, which means all the chaos resources are going to be created and maintained in the Litmus namespace. So the admin mode namespace can be something that's other than Litmus. You can tune that in your Helm chart. For now, we're going to use Litmus. So I have got my chaos experiment here. So let's check if the experiment is actually pulled, if the resource is actually created. Yeah, I have got the pod delete experiment. Now, going back to this diagram, which I showed you a few minutes back, I'm an SRE or a developer who wants to do chaos, and I have an application here. In my case, this is Nginx. And I've pulled the necessary experiments from Chaos Hub. And the Chaos Hub is akin to a marketplace for chaos. You have members of the application community coming and placing their experiments there. And they're also the consumers of these experiments. So we've got the experiment pulled from there. And the next step is going to create the chaos engine. We already have the operator, which is going to watch for the creation of this chaos engine, and it's going to spawn off a set of steps. It's going to create some resources. We're going to see this when it happens. I have already got the chaos engine with me. But before I create the chaos engine, I'm going to create the service account that is going to be used in the admin mode. So just to recap, we said in the admin mode, all chaos resources are going to be in the Litmus namespace, and it can execute chaos on applications that are spread across different namespaces. So that means the service account should have the capability to inject the chaos, different kinds of chaos, against applications residing in different namespaces. That means it has cluster-wide scope. I have the command that is going to install the admin mode service account for me. So let me execute that. This is created. Prior to this, you might have seen that there was a service account created to the operator. So you want to ask, what is the difference between that and this? It's very simple. The operator service account is fairly restricted, and it gives the permissions that are necessary to just watch the chaos engine resources and create the secondary resources like the runner and the experiments, but it really is not capable of doing chaos by itself, which is where the Litmus admin mode RBAC comes into play. The next step is to construct the chaos engine, and the chaos engine looks like this. So there is a very defined structure for the chaos engine, and you can neatly split it into several parts. There is a section which actually talks about the application under test, the AUT. So in our case, you can see that that is the app info. The app info portion of the spec contains information about the application you're actually going to inject chaos on. So it is running in the default namespace. It bears a label called run equals to nginx, and it is of kind deployment. Litmus supports different kind of Kubernetes resources, Kubernetes controllers, such as deployments, daemon sets, stateful sets, etc. And it also supports some of the OpenShift resources, such as deployment config. So the other portion of the chaos engine spec that you can see in this section below, after the app info, is corresponding to the run policy. When I say run policy, this is about what do you want to do during the experiment run or after it. For example, if I want to say that pick a very specific Nginx deployment amongst many other apps which bear the same label, let's say there are different Nginx instances that are running, or there are, and this is not just applicable to Nginx, it's a common thing for any application. You have various applications running on your namespace, the target namespace, which bear the same label. In that case, you want to limit the blast radius only to the specific application. You can do this annotation check. If this is set to false, it's basically going to filter only by label and kill all the pods that you might have specified. If you have set this to true, then that means it's going to zero in on only that deployment which is containing this annotation called litmuschaos.io/chaos set to true. I'm going to show you that in a bit. The other run policy is the engine state. Sometimes, especially on production, you see that you want to stop the chaos midway. The chaos experiment might be running for a defined period, but you want to revert the impact of chaos immediately. So you can actually abort the experiment by patching the engine with an engine state set to stop. That's going to remove all the chaos resources. And the next one is the auxiliary app info. The experiment is by default designed to look for the health of this application as part of its execution. So it does a pre-chaos check and a post-chaos check on the application defined in the app info. But sometimes that itself is not sufficient. You might have a lot of downstream applications which are dependent upon the app that you are going to inject chaos on. And as a part of your experiment run, you want to verify the health of those auxiliary applications as well. That's where this comes into picture. You provide the details of a namespace, and label key value pair is going to be provided here. You can provide a comma separated list of namespace key value pairs of the auxiliary applications, and that's going to be involved as part of the experiment, is going to be included along with the primary application. Then you have the chaos service account. This is Litmus admin, and when you're running in namespace mode, you're actually going to have your own service account here with just the permissions necessary to run that particular experiment, restricted to that namespace. Monitoring is about whether you want to capture the chaos metrics as the experiment runs. You might want to check what are the total number of experiments that are available in the engine. And we're going to touch upon that in a bit. You can actually run more than one experiment as part of the engine in a sequential manner. Whether you want to collect those details, how many experiments are there, how many of them passed, how many of them failed, etc. So all those information can be derived by the chaos monitor. And for the chaos monitor to be able to pick that info off this engine, you need to be setting this monitoring to true. We're not going to monitor that right now, so I've set it to false. And the next policy is job cleanup policy, the next attribute. This is going to determine whether you want to retain the chaos resources that you ran as part of the experiment, or you want to delete them immediately after ending the experiment. Sometimes when you're running on development clusters without the support or benefit of Fluentd or ELK or any kind of monitoring or any kind of logging infrastructure, you might want to keep those pods, the chaos resources, to go check the logs and find out what happened in your experiment run. Especially when you're building new experiments by using the Litmus SDK, you might want to do your initial few runs with the job cleanup policy set to retain instead of delete, to see whether the experiment has executed the way you intended it to be or no. So this was about the run policies in the chaos engine. So this was the app information that you were providing, and this is about how you wanted experiment to run, what you want it to do as part of its run, and then the experiment itself. So in this chaos engine, I have a single experiment, a single chaos experiment to be executed against the Nginx app, that is pod delete. And the experiment portion can actually take a lot of rich schema in terms of overriding the experiment defaults. Now, the experiment that we pulled a few minutes ago from the chaos hub has a set of defaults for pod delete. When I say defaults, these are the chaos tunables, such as chaos duration, how long you want these pod delete operations to happen, what the interval is, that is, how many times or what interval with which you want to inject the pod delete. So with a duration of 20 seconds and interval of 10, you expect that the chaos happens twice. And what kind of pod delete do you want? Do you want to do graceful deletes? Do you want to do forced deletes, etc.? So these are some of the attributes that are corresponding to pod delete, whereas with other experiments, you have their own set of chaos tunables. You have the option to override some defaults set in that experiment here through the components.env inside the chaos engine spec. And there are other things inside the components that you might want to set. Sometimes some experiment execution needs some data that you want to pass from the outside. You might want to push some config information, or in case you're running on some kind of a cloud provider, you might want to specify some access information via secrets. Sometimes you might want to mount some files on your host as part of the execution. Sometimes you might want to run the experiment pod on a specific node. These are all various tunables that you can make inside the experiment.spec.components section. You can visit this page on the experiment docs. The docs.litmuschaos.io has a section that is dedicated to explaining the chaos engine schema. And it is divided on the lines that we just discussed: the application specification, the RBAC specification, the runtime specification, the run policy, the component specification, which is something that we are not seeing right now, but it is how you want to run your chaos runner and monitors. And then the experiment specification that is talking about what are the various fields that you can, what are the various overrides you can do, what are the various information that you can pass on an instance basis. So note this word instance basis. The chaos engine we just mentioned is a user-facing CR, and it is the one where you're actually giving information in a dynamic way. So this can change, your application information can change, your run policy can change. These are all dynamic instance-specific information that you provide. Whereas the chaos engine that you pulled contains static information. That is something that is not going to change, and that is why it is on the hub, and it is pullable in an off-the-shelf manner. When I look at the chaos experiment, we are actually going to see what information it is contained within the experiment, how it is constructed. That will give you a picture of what the engine is going to superimpose on the experiment. Let me do a -o YAML of the chaos experiment for pod delete, and let's see what it actually contains. Let me quickly move on to the field called definition. The spec.definition is the critical portion of the chaos experiment. And you can see here that an experiment image has been specified. So this is the image that contains the logic that is going to run the pod delete. And it is specifying an entry point. It's going to specify the command that is actually running the pod delete experiment. So in this experiment, I'm going to select this binary within this image with this environment variables, which I can override on my engine. And there are also some other attributes here, such as the labels, so that I can recognize this pod if I'm using a tool to monitor this. And there are also some permissions. The spec.definition.permissions talks about what really you need to run this experiment in terms of supported resource actions, etc. So we are actually going to run this chaos engine now. And going back to the slides, now you can see the portion on top. So all that we talked about here, the chaos hub, the experiment, the engine, the application, now we are clear with this part. Now we are going to see what happens below. That is the part after the chaos operator starts pitching in. So in our series of steps, we have completed this. We've created the operator, we've pulled the experiment charts, we've set up the service account, and we've constructed the chaos engine. Now I am going to trigger the experiment by applying the chaos engine. And as we do that, a set of resources are going to get created, and we'll see what they are. So I've created the chaos engine, and let me look at what is happening on the Litmus namespace. We are running in admin mode, as you can remember. You see that there is an Nginx chaos runner pod that got created, and there's also a pod delete experiment pod that has got created. Now the runner is an umbrella executor. You can think of it as the piece of Litmus that maintains the lifecycle of the experiments. Now, you might have several experiments, so the runner is going to create them in a sequential manner. It's going to monitor the experiment execution, and it's going to remove the pods created as part of the experiment run itself. And let's also quickly take a look at what is happening on the application. Oops. Let me run the correct. You can see that this application actually got killed, and the age is now 23 seconds. It's newly spawned this pod. So the experiment actually went ahead and killed this pod, and now a new pod was created because this is a deployment. I've expected a couple of chaos iterations. That is, a pod delete happens a couple of times, and then after that it ends. I'll confirm that. You can see that the chaos is reverted now. There are no chaos runner pods or no experiment pods that are there. They just got removed because we used a job cleanup policy of delete. So after the experiment was executed, it has now removed all the chaos resources that it created. Now you might ask, what actually happened during the course of the experiment? Is there a way for me to track the various stages of an experiment? This part's a little too quickly, but you don't have to worry. You can actually see the chaos engine in Litmus and just do a describe, and you will see what all has happened. You can see these events. Right when we created the chaos engine, we got this event that said chaos engine is initialized, and it created the Nginx chaos runner. the umbrella executor, which manages the life cycle of the experiments. Then after that, there was an experiment dependency check that was carried out. And the experiment dependency check in our case just meant to see if the application pod was live. Can I go ahead and kill it? Is there any config map or secret I need to pass? Is there any prerequisites for doing this experiment? In our case, we didn't have any, whereas in several application-specific chaos experiments, you have a lot of dependency checks you have to perform. So that happened successfully, and then the experiment job was created. After the experiment job was created, and you can see the sources of these events changing here. Each piece of Litmus is actually generating its own events as we go. The experiment then actually generated a pre-chaos check to do a series of steady state checks or health checks against the Nginx pod. After that, it injected the chaos, and it has injected it a couple of times. You can see the iterations here. It has injected the chaos a couple of times. So 2 pod deletes have happened quickly over a period of 20 seconds. And after that happens, doing a post-chaos check. So in the generic experiment for pod delete, a post-chaos check is only going to see whether the app is back online, the service is alive. And once that was confirmed, we actually did a summary event which said that the pod delete experiment has succeeded, it has passed. And then because your job cleanup policy was delete, it's cleaned up. This again is generated by the runner, and then the operator removes the runner to complete the experiment run. So these are the sequence of events that has happened during the course of the experiment. Right? Now, let's go back to our slides and see what has happened after we created the engine. We're just doing a small recap. The chaos runner was created. The runner created the job. And like I mentioned, you can actually create several jobs based on several experiments. And then the experiment job induced chaos back on the application. And once the application was killed, the experiment job did a post-chaos check and then put out its verdict on what happened. The verdict in this experiment is pass. And you can also see there is a chaos result custom resource which is giving you that same information. Now you might ask, what is the need of the chaos result? The chaos result actually stores the details of the experiment run in a way that is useful to the developer or SRE. You can see the schema of the chaos result. So whenever there is an experiment failure, you actually go and point out the step where the experiment has failed. In this case, it is not applicable. And the phase of the experiment is completed. The phase of the experiment is going to be awaited when the experiment job is not created yet, the chaos is not injected yet. It's going to be running when the experiment job is in progress, and it's going to be completed after the experiment is finished. And the verdict is basically based on your post-chaos checks, and then there is a summary event associated with the result as well. The chaos result has scope for a lot of schema improvements, and that is something that is underway where a lot of information about the experiment can be packed into the chaos result. Sometimes that would mean number of successful requests, it could mean the performance, it could mean the other salient features of the application that you would like the user to know when the experiment ran. All this information is going to be packed inside of the chaos result, and it is especially beneficial in case of application-specific chaos experiments. Now, this is what has happened. Now we are putting things together, and you could see this whole life cycle just play out in front of your eyes. We are going to do a small recap. I have explained what the experiment looks like, what the engine looks like, and what the result looks like. We're just going to summarize the same here. And we're going to also classify it on the basis of when they are actually going to play in Litmus. The chaos experiment is pre-built, and it contains the granular definitions of chaos intent, things like you saw, the duration, the intervals, things like the nature of the kills, etc., pop or delete. It could mean so many other things for other experiments. For network chaos, it might mean latency, it mean the loss percentage, it could mean the jitter percentage, so many other things. It's also specifying what is the image you can run it with. And this is where Litmus also supports the BYOC mode, that is the bring your own chaos mode of execution, where you can specify your own chaos image. You can execute the chaos the way you want it, with the checks that you want, and you can put that image in the chaos experiment and provide the necessary tunables and the necessary permissions. The next one, the chaos engine, you saw is user-defined. We constructed it. We placed the right information over there. And that is the one which is going to bind an instance of a given application with one or more chaos experiments. And it is going to help you define the run characteristics, override defaults, and also is the one that's actually being reconciled by the chaos operator. The next one is the chaos schedule, which we did not look at in this demo, but it is going to help you schedule your chaos in a repeated fashion. There are a lot of different repeatability modes supported in the chaos schedule CR, such as you run it once, you run it across a range between a start and end timestamp with some intervals or instance counts. You can do the chaos randomly, or you can strictly schedule it. These are all possible with chaos schedule. And then the result, which is going to hold the experiment state, the verdict, and it also happens to be the source for the creation of the metrics when the monitor is installed. So this was the orchestration workflow that happened. This is a swim lane diagram which is explaining user actions, the chaos orchestration actions as split between the operator and the runner, and what happens within an experiment execution itself. The user action goes like this. He actually creates a chaos engine CR by mapping an application instance to the experiment. And the operator is going to look at this chaos engine CR. It's going to read all the runtime properties, and it's going to create a chaos runner pod to manage the lifecycle of the experiments in the chaos engine. And the Litmus chaos runner is actually going to then look for a series of things. It's going to look for the availability of the experiment. It's going to validate experiment dependencies. And it's going to override the defaults and construct the experiment job and launch it. The experiment then performs the pre-chaos steady checks. So you might ask, what is this experiment dependency versus these steady state checks? Why are we doing so many dependency checks again and again? So just to reiterate, these experiment dependency checks is about what is necessary for the experiment to run in terms of the resources that are needed on the cluster. Whether you need the right permissions, you need the right service account, you need the right config map or secrets passed, whether you need volumes. These are the dependency checks for running the experiment itself. And the pre-chaos steady state checks that are performed here are checking for the application state. And you might want certain conditions fulfilled on your application stack before you run your chaos. In our case, we just looked if the Nginx pod is alive, but it might be much more complex than that. So these are the differences. So the experiment performs the steady state checks, injects chaos, and performs the post-chaos check. And it is going to patch the chaos result CR at the beginning and at the end with the state of the experiment. And the chaos runner, which is looking at the chaos result, is going to patch the state back into the chaos engine. And the chaos engine is going to be the single source of truth for a user. He need not, if at all, he's not really interested in the granular details of an experiment, can still just view the experiment, the engine CR, pardon me, to look at the status of the experiment and to find out what is going on as part of an experiment through the events. Though there are some optional flows that can happen, you can choose to abort the experiment. And if you do that, the operator is going to reconcile that change, that the operation that you made to patch your engine with an abort state, and it's actually going to remove the chaos runner and the experiments. A cascading effect ensues where the runner and the experiment and any other chaos resource that you would have created as part of the experiment to be removed. Now, you could also change certain other characteristics of the experiment. You can go to the engine and change one of the tunables that you might have been overriding. Let's say I change it to 30 seconds over 20 seconds. So that is a change in the experiment spec. So the operator can reconcile that change as well and re-trigger the experiment with a new set of tunables, and the same cycle is going to be repeated. So this is what happens as part of the orchestration workflow. This is what the user does. He's going to run an engine and he's going to patch an engine, is going to view an engine, whereas the operator internally is going to take care of launching the necessary resources and running the experiment. And the experiment itself is going to inject the chaos on the application and is going to look for a set of probes or a set of checks that the experiment mandates to say that the application is all hale and healthy and the experiment has succeeded in its intent. This is another slide that I've just created to explain in detail what the experiment job does. The actual chaos experiment follows this process. It is going to take information around these things. It's going to take the library as in you might choose to use native Litmus libraries to run your experiment. Sometimes you might have your own chaos. You might have specified that inside of a chaos lib. You might have created separate images to do that. So you're going to specify that information, then the chaos tunables, and then the app information. So whatever you provided in the chaos engine and experiment is going to be distilled and going to be passed into the experiment job. So this is what we are referring to as user inputs. The c.eng and c.experiment are nothing but the chaos engine and chaos experiment, which is where your inputs are coming in. And then you run the experiment and you process these inputs and then you patch the experiment result with the right state. In this case, you're going to initialize it and say the experiment is just getting started, it is running. Then you're going to perform the steady state checks. And at each stage, you're going to see these events created. And since we ran the experiment right at the beginning of this session, you know, and you've seen these events that got created. The steady state check upon passing is going to create a pre-chaos event. And it's saying that the pre-chaos checks are successful. They're going to launch chaos resources. Many times the experiment pod itself is going to do your chaos injection. Sometimes we make use of what are called as helper pods or auxiliary pods, which are going to perform a very, very specific function. For example, sometimes you're going to do the kubelet service kill experiment or a Docker service kill experiment. In this case, the experiment pod is actually going to launch another container which is going to execute the commands or the calls necessary for doing the service crashes. So these are called helper resources, and this is what this particular block indicates in this flow diagram. You're going to launch the chaos resources, and then you're going to inject the chaos, and sometimes you're going to iterate. Sometimes you might not iterate and might just do one instance of chaos. That's just left to you. And upon doing this, you're going to create a chaos inject event just before you're going to do the chaos injection. Then you're going to revert the chaos after you've finished. Then you're going to do a post-chaos check. And if that is successful, or if it is failed, accordingly, you're going to create a post-chaos event. And if all goes well, then you're going to pass the experiment. That is, you're going to patch the result resource with the verdict that says pass, and you're going to end the experiment with a summary event. If it is going to fail, if your application did not recover in time, if your post-chaos checks were not fulfilled, then you're going to provide the fail step. What point of the experiment it actually, what step of the experiment it actually failed at. This is going to help you with your root cause analysis. And you're going to patch the experiment, the chaos result with the failed verdict. Now you can see that there's also another path here. Your steady state check fails even before you launch chaos resources. Then you're not going to proceed with the experiment. You say the experiment is ended, it is failed. You're not having the right conditions to run the experiment. So these are the steady state checks and post state checks are very significant, and they are the crux in determining whether you choose to say your experiment has passed or failed. So we mentioned that you're going to do checks before and after chaos, but that's not going to be sufficient, is it? Because you might want to continuously evaluate the availability of certain services when you run chaos. That is where these experiment probes play. These experiment probes can be defined in the engine in a declarative manner, and there are some improvements around this that are coming up in the releases that are going to come in the next month. You're actually going to see whether a service is going to be alive throughout the execution. Sometimes it's not just service availability. You might want to check some metric that is related to your application, or that is related to some downstream application, depending on the application you're going to kill or inject chaos on. You might want to verify that on a continuous basis as you run the chaos. So you're not going to check, you're not only going to check what happens before and after you run the experiment, you're also going to check what happened during the experiment. And that is also going to play a part in determining whether your experiment is really succeeded or no. So your post-chaos check is also going to involve an additional step, just going to verify if your probe is being returning the right things always. At any point, if the probe fails, then you're actually going to fail the experiment. So this is what happens when you run the chaos experiment. So this was about the anatomy of the experiment run itself. And this was about the overall orchestration, what happens when you run the experiment and how the different components play. So with this knowledge, you now know that Litmus is basically a set of CRDs, a set of components that are going to watch these CRDs and execute certain functions. And it is the chaos hub, which is basically the location where you're going to hold all the details of what each experiment does. This is what the Litmus architecture is comprised of at a high level. And in subsequent sessions, we'll take a look at how all these pieces are tied together, what are the different integration points, and how you can actually write a new experiment, how you can make changes to the chaos operating to the framework, etc. Thank you.